Hello and welcome to my teaching video about planetary environments of the Mars. This is the second chapter of the book Planetary Rovers by Professor Alex Ellery, and I'm doing this video as part of the seminar Planetary Exploration. So first of all, we gotta ask ourselves, why are planetary environments so important? So the primary goal for a planetary rover is to navigate and traverse unknown and hostile terrain. A rover should recognize and negotiate obstacles, be able to deploy scientific instrumentation, acquire samples, and more. There's a huge range of planetary environments, from benign and flat to extremely rocky and hostile. The last part we mostly find on Mars, but more about that later. And to prepare your rover with best chances of success, it is important to know as much as possible about the environment of the specific planet you're sending the rover to. The structure of my video is as following. First of all, I'm going to talk about some critical constraints for rovers. Then I'm going to give you some overall facts about Mars, about the orbit and rotation. I'm going to talk about the surface and the atmosphere. And in the end, of course, you're going to see my sources. But also in the end, I'm going to show you some extras. For example, a summary video of the Perseverance rover mission on Mars, which I thought was pretty interesting. So the first topic is critical constraints for rovers. On a planet like Mars, there's an adverse terrain characterized by rocks and cliffs with just a few features for self-localization, which is a crucial issue for the autonomy of the rover. There's always a lack of data on specific features of the environment, especially on planets where the humankind has never actually been to by themselves. You have to keep in mind the long flight times, which lead to limited communication windows to Earth, and also they imply a need for high degrees of autonomy of the rover. For example, the Curiosity rover mission, there was a mean delay of 13 minutes, but one way, so you had to wait 26 minutes to see what happened when you did a command on the rover back on Earth. Also, there are always hostile ambient conditions like thermal extremes and dust environments. There's limited power availability, so you have to keep other power sources in mind. For example, sun energy is always a good alternative. And there are high reliability requirements, which limit the mechanical complexity of the rover. If you compare those critical constraints to the constraints for a terrestrial mobile robot, those constraints are much more stringent, because you can't just send the Mars rover back to Earth if something is broken. The next topic are the overall facts about Mars. You can divide the Martian terrain into 5 major divisions: the highland rock, the lowland rock, the volcanic regions, the channel systems, and the polar regions. The northern hemisphere of the Mars is very flat, and the southern hemisphere is mountainous, which you can also see in the next slide. So here you can see the topography of Mars, which was shot by the Mars Orbiter Laser Altimeter, or MOLA. And as I said earlier, the northern hemisphere is very flat. It has an average elevation of -1 to -3 kilometers, and the southern hemisphere is very mountainous. It has an average elevation of 4 kilometers. There are also some irregularities, which you can see. For example, this is Olympus Mons, which is a large volcano. This is a large canyon system called Valles Marineris, but I'm going to talk about those two especially later. And also there's a big basin. Now I'm going to talk about some other overall facts, which are much more general. For example, the diameter of Mars is 6,742.4 kilometers. In comparison to the diameter of Earth, it's nearly half, because the diameter of Earth is 12,800 around. Then the mass of Mars is 642 sextillion kilograms, so it's 642 and 21 zeros kilogram. Then the average distance from Sun to Mars is 229 million kilometers. In comparison to the average distance from Sun to Earth, it's 150 million kilometers, so 1 astronomical unit. And also the volume of Mars is around 1/6 of the volume of the Earth. For visualization purposes, here's a picture of Mars and Earth in comparison. So here you can see that Mars is much smaller than the Earth. So if you look at the gravity of Mars, Mars has a gravity which is around 0.375 in comparison of the gravity on Earth. And here's a nice visualization of that, which I found on the NASA website. So it says on Mars you'd experience 62.5% less gravity than you used to. And you see the little guy jumping much more higher and slower than he would do on Earth. So I thought it was pretty interesting and a pretty good visualization. And last of all, we're going to talk about the 2 moons of Mars, which I thought was pretty interesting because I didn't know in the first place that Mars even had moons. So it has 2 moons, which are called Phobos and Deimos. So here you see the 2 moons. Phobos is on the left and Deimos is on the right. Phobos has a mass of 10.8 times 10 to the power of 15 kilograms, and Deimos has a mass of 1.8 times 10 to the power of 15 kilograms. So yeah, Deimos has around 1/6 of the mass of Phobos. And also Phobos' mean distance from Mars is around 9,000 kilometers, and Deimos' mean distance from Mars is around 23,000 kilometers. Which I thought was most interesting about those 2 moons was that they were so weirdly shaped. And I also read on the NASA website that some scientists thought that those are just asteroids which were caught by the gravity of Mars. And just in comparison to how our moon looks like, those look, yeah, a little bit weird. And here's also a video I wanted to share with you because I thought it was pretty interesting. It's NASA's Perseverance rover, which shot a video of Phobos eclipsing the sun with its Mastcam Z camera. So Phobos, the left one, the bigger one, you see here eclipsing the sun. Phobos with its potato shape. And the eclipse is around 40 seconds long, so the eclipse is much shorter than the typical eclipse involving Earth's moon. And yeah, that's because Phobos is around 157 times smaller than Earth's moon. And yeah, as you think, Deimos is even smaller. Yeah, and that's just a video I wanted to share with you because I thought it was very high quality and yeah, very interesting to see because it was shot by a Mars rover from Mars and it was a solar eclipse. So the next topic we're going to talk about is orbit and rotation. As all other planets in the solar system, Mars orbits the Sun. 1 year on Mars is 669.6 sols, so solar days, which the Martian days are called, though this number is equal to 687 Earth days. Also, one rotation around itself, so 1 day on Mars is 24.6 hours. In comparison to the Earth day, it's very similar with 23.9 hours. Its axis of rotation is 25 degrees, which is also very similar to the Earth axis of rotation, which is around 23 degrees. But this axis of rotation wasn't always at 25 degrees. The spin axis has wildly varied from 0 to 60 degrees, which also had a high impact on the climate. And in the past 20 million years, the obliquity of Mars was closer to 45 degrees, which led to a warming of higher latitudes, vaporizing ground ice near the surface. And also the axis of rotation can lean as far as 60 degrees, thus generating a thick atmosphere due to the polar ice evaporation. Now, if you look at the seasons on Mars, they vary in length. Seasons compared to the Earth, they are not evenly spread. They vary because of the elliptical and egg-shaped orbit of the Mars. So the next topic is the surface of the Mars. This is a very important topic if you look at it from the perspective of Mars rovers, because the rover lands on the surface and has to deal with the surface on every day of its mission. Mars is called the red planet, as you probably know, but its surface has actually many colors, such as brown, gold, and tan. The reason for the redness is the oxidation or the rusting of iron in rocks, the regolith, the Martian soil, and dust. This dust gets kicked up into the atmosphere, and from distance the Mars appears mostly red. Also, Mars' diameter is around half the diameter of the Earth, but it has nearly the same area as Earth's dry land. The reason for that is that Mars has many volcanoes, impact craters, there's crustal movement, and the atmospheric conditions such as sandstorms. There's also a large canyon system called Valles Marineris, as I mentioned earlier, which I thought was pretty impressive because it's 4,800 kilometers long, 320 kilometers at its widest, and 7 kilometers at its deepest. And it's 10 times the size of the Grand Canyon. And if you saw the Grand Canyon, this is huge, and yeah, you can imagine how huge the Valles Marineris is. Then another interesting thing is Olympus Mons, which is a large volcano. It's actually the largest volcano in the solar system, and it's 3 times taller than the Mount Everest, so around 25 kilometers. Here you see again the topography of Mars shot by the MOLA. As I said earlier, this is Olympus Mons and this is Valles Marineris. And just for your interest, this is also a volcano called Albas Mons, which has the biggest area on Mars for a volcano. Those 3 are also volcanoes called the Tharsis Montes. Those are 3 shield volcanoes, which are called Ascreus Mons, Pavonis Mons, and Asia Mons. And as I also mentioned earlier, this is Hellas Basin, which is more than 7,000 meters deep. And I just thought it was pretty interesting which irregularities were found on Mars. So the big question always was, is there liquid water on Mars on the surface? So Mars has a watery past. There were found ancient river valley networks, deltas, and lake beds, and also rocks and minerals like jarosite, gray hematite, and goethite on the surface that could have only formed in liquid water. There are also some features that indicate huge floods 3.5 billion years ago. So the question is there liquid water on Mars today? So no, there's no liquid water, but there is water on Mars. The atmosphere is just too thin for liquid water to long exist on the surface. So there exists water in form of water ice under the surface in the polar regions. And also there's briny water, so salty water, which seasonally flows down some hillsides and crater walls. The next topic is the atmosphere of Mars. Mars in general has a very thin atmosphere, which contains of carbon dioxide with 96%, nitrogen and argon gases with around each 2%, and some other things as well. The temperature on Mars ranges from minus 153 degrees Celsius to 20 degrees Celsius. But because of the thin atmosphere, heat from the sun easily escapes from the surface of Mars. So if you stand on the surface of Mars on the equator at noon, it would be 24 degrees Celsius at your feet and around 0 degrees Celsius at your head. So it's like winter at your head and spring at your feet. That's just an interesting thing I read. Also, there can be strong winds on Mars that can be strong enough to create dust storms which cover much of the planet, and after that it can take months for the dust to settle. And this is also a thing you have to keep in mind, because the dust can get into the joints of the rover and damage it, and also can impact your scientific instrumentation, and thus maybe falsify your results. At the end of the video, there's some extras I thought were fitting for this video. A few weeks ago, I was visiting a friend in Bonn and we took a bike trip along the Rhine. And there we stumbled across something which is called a planet path, which is an educational path about the planets of our solar system. I took those 3 pictures when I was there. Those bronze tables were built along the path, and the distance between the tables were equal to the distance between the planets of the solar system, with the right scale, of course. So, for example, the bronze table of the Earth was 150 meters away from the bronze table of the Sun, and the bronze table of Mars was 229 meters away from the Sun. I thought it was a pretty nice way for everyone to learn about the planets of the solar system, and yeah, I wanted to share it with you. In the end, I also wanted to show you a review video of the Perseverance rover mission, and this video was published earlier this year.
Touchdown confirmed. In the 10 months since the rover has landed, we've been busy, and it's been a year of perseverance. From operating during COVID to the challenges we experienced with sampling to interpreting the scientific results. It's such an appropriate name for the vehicle, but also for the team and the mission itself. This mission has a series of firsts that will help future generations understand more about our solar system. One of my favorite moments was seeing our first rock core sample, looking down the tube when it was still in the drill bit and confirming that it was indeed a success. Now that we've collected samples, everyone wants to know when and how they'll be coming back. We can't wait for the future mission to pick them up and ferry them to Earth to analyze if any of them show signs of ancient life.
The first flight of a powered aircraft to another planet.
Another highlight of this year was working with the helicopter team to deploy Ingenuity and experience the first powered flight on another planet. It was so amazing to see the team adapt to the environmental changes in order to keep flying. The helicopter has become a real asset and partner to our science team. It feels great to be part of making history. What motivates us as engineers and scientists exploring another planet is the opportunity to continuously learn more. Now that we've toured the floor of Jezero Crater, we look forward to investigating the Delta, a part of the crater where a river fed into a lake in the distant past. It's almost as if we're starting a new mission because we'll start to cover new ground and make new scientific discoveries. What I'm most proud of is the team, how we operate the rover, overcome challenges, and the dedication that everyone brings to their job each and every day.
All right.
So in the end, here are my sources. I took a lot of information from the official NASA website because I thought it was a pretty good source. And also the NASA website is very good. I can highly recommend it because it has so much information about every mission and every planet. So if you're interested in that, just look it up and I can highly recommend it. And also here's the link to the YouTube video And also YouTube has so much content about Mars and also all the other planets. I could spend hours on YouTube just searching through the videos of Mars. Yeah. And also this is the book the seminar was based about. And in the end, I just want to say thank you for watching the video and bye.